Hello there, college algebra students. This video covers radical equations. The process that we're going to use to solve these, I've typed up here. We're going to first isolate the radical, and then we're going to raise each side of the equation to a power equal to the index of the radical. Excuse me. We are going to check our solutions when the index is even because we have a chance of getting extraneous solutions. All right, let's take a look here. So starting with number one is a square root. The index of a square root is 2. So I'm going to square both sides of this equation in order to remove the radical or the square root from the equation and solve. Now, I didn't have to worry about isolating the radical. It was already by itself on the left-hand side of the equation. After squaring both sides, well, when we square a square root, we just get the radicand. Squaring a square root takes care of that, or removes the square root from the equation. We're also going to square 3, and we get 9. From here, we just solve. It's just a two-step equation here. So 2x equals 10, and x equals 5. And then because the index is even, we do want to check our answers because we do have the possibility of getting an extraneous solution. So let's see if our solution, our answer 5, works in the original equation. So I'll put a little question mark here because we're not sure if they truly are equal. So I took my 5 and I plugged it in for x into the equation, and I get the square root of 10 minus 1, and we want to know if that equals 3. And sure enough, it does. The square root of 9 equals 3. So our solution is a good solution. It's not extraneous. The solution to this equation is x equals 5. Okay, let's look at number 2. This one, we're going to have to isolate the square root. We want it by itself on one side of the equation. And when you're isolating a square root, we're always going to add or subtract before we multiply or divide. Same rules as a normal equation, like up here, instead of dividing by 2, we added 1 to both sides first. The same thing, we're going to add or subtract before we multiply or divide. When I subtract 5 from both sides, 9 minus 5 is 4. And then I'll divide both sides of the equation by 2. And I have now the square root of 4x minus 2 equals 2. Now we're back to the same type of problem as number 1. I've isolated the square root. Now I'm going to square both sides to finish solving this equation. When we square the square root of 4x plus 2, we just get 4x plus 2. When you square 2, you get 4. And I'll solve this two-step equation here. And I'm getting that x equals 1/2. Now, before I say that is definitely my solution, I'm going to do a quick check. So I'm going to plug this in to see if it makes a true statement. Now you can plug it into the original. You could also plug it in down here if you'd like. Now hopefully you did all your math correct up until this point. So I guess you're a little bit of a risk plugging it in down here. I'll go ahead. I'm going to plug it in down here, but again, like I said, be careful because if you've done something silly with your math, then it's not going to work when maybe it truly is a good solution. So I'm going to move, nope, my x equals 2 moved down there. That's okay. Okay, so here I'm going to do, or my x equals 1/2. Here, I'm gonna put it back up here again. Okay, so ignore that there. All right, so x equals 1/2. So let's see if this is a good solution. So square root 4 times 1/2 plus 2, and we want to know, does this equal 2? 4 times 1/2 is 2. So does the square root of 4 equal 2? Yes, it does. So x equals 1/2 is our solution to this square root equation. All right, let's look at another one. Number 3. Number 3, this time we have a cube root. And we're going to raise both sides of the equation to the third power. We need to raise it to the power, to a power that is equal to the index of the radical. When you cube a cube root, you just get what's underneath, the radicand. So 3x minus 4 equals 8, and we solve the equation. Good news is, when you solve radical equations with an odd index, you do not need to check your answer. Now, it's always a good idea to check your answer, but you do not need to check your answer. We do not get extraneous solutions when the index is odd. Okay, let's look at number 4 now. Number 4, the fifth root of 2x squared plus 9 minus 4 equals 0. We do need to isolate the radical in this one. So the fifth root of 2x squared plus 9 equals 4. Then we're going to raise both sides of this equation to the fifth power. When we raise a fifth root to the fifth power, we just get the radicand. 4 to the fifth power is 1024. And then we need to solve this equation to get our, it looks like we're going to get 2 solutions here. So let's see. I'll subtract 9 from both sides. Subtracting 9, we get 2x squared equals 1015. Then we can divide both sides of the equation by 2. Therefore, x squared equals 1015 over 2. Now I'm going to use the square root property to finish this. The square root property says if x squared equals d, then x equals plus or minus the square root of d. So we're going to have 2 solutions here. X will equal the square root of 1015 over 2, and also negative square root 1015 over 2. Now, in just a second here, I'm going to rationalize those denominators because we don't want to leave a square root in our denominator. So I'll make these answers look a little better. But I do want to point out, good news, we have an odd index, which means we do not have to check our answers. So as long as your math is correct, then those would be 2 good solutions. So let me show you how we can rationalize the denominator here real quick to get the best answer possible. All right, so I'm going to look real quick at the square root of 1015 over 2. This is the same thing as the square root of 1015 over the square root of 2. So let me rationalize this denominator here. I'm going to multiply by square root 2 over square root 2 to get square root 2030 over square root 4. And so this would be square root 2030 over 2. So that is the same thing as this here. I've just rationalized the denominator. So the best answers for this problem would be square root 2030 over 2 and also negative square root 2030 over 2. Okay, like I said, we don't have to check our answers. It's always a good idea to check your answers. This one is going to be a little tougher because we've got some pretty crazy answers here. But as long as our math is good, we can be guaranteed that these are two good solutions to that radical equation. Okay, let's look at number 5 here. So number 5, we have square roots on both sides of the equation. So I'm going to start and I'm going to square both sides. And when I square both sides, I just have this equation here. And to solve this equation, I'm first going to subtract 4x from both sides. So I have x minus 1 equals negative 7. Then I'm going to add 1 to both sides. And so I have x equals negative 6. Now I need to check my solution because I have an even index. So let's check and see what we have. So I'm going to plug in negative 6. And I'm going to plug it into all x's in the problem. And I'll put a little question mark there because we're not sure if those are going to be equivalent or not. So underneath the first square root, I get negative 31. Under the next square root, the second square root, I also get negative 31. Now, technically, the square root of negative 31 does equal the square root of negative 31. But we have a problem because the square root of negative 31 is not a real number. So this solution here, or this possible solution, is not really a solution because when I plug it in, I'm not getting real numbers. So I'm going to cross this off. This radical equation or square root equation has no solution. It has no solution because although these two are equal, they're not real numbers. And so no solution will give us real numbers or the same real number on both sides of the equation. So that would be an example of an extraneous solution. Okay, let's do one more in this video. This is our last one. This one also has the possibility of extraneous solutions. So let's see what happens here. So I need to isolate the square root. And to isolate the square root, I'm going to subtract 3 from both sides. So I get the square root of 3x plus 1 equals x minus 3. Now, x minus 3, I can't simplify that any further. They're not like terms, so I just have to leave it as x minus 3. Then I want to raise both sides of the equation to the power equal to the index, which means I'm going to square both sides. And when I square a square root, I just get the radicand. Now, on the right-hand side of this equation, when we square a binomial, we're going to have to FOIL here. So it's x minus 3 times the quantity x minus 3. So let's see what we get here. So x squared minus 3x minus 3x plus 9. And let me combine like terms. Now be careful, don't cancel these. It's x squared minus 6x plus 9. Both of those three x's are negative. Okay, so now I have a quadratic equation. And to solve a quadratic equation, we could use the quadratic formula. We could also see if possibly this factors. It's going to be a little quicker if it does factor. So I'm going to get a 0 on one side of the equation. So I'm going to subtract 3x. I'm also going to subtract 1 from both sides. And so I get 0 equals x squared minus 9x plus 8. And this does factor. I can look for two numbers that add to negative 9 and multiply to 8. Those two numbers are negative 1 and negative 8. So that means that this trinomial factors into x minus 1 times the quantity x minus 8. I have two possible solutions. X minus 1 equals 0 or x minus 8 equals 0. So that means that x equals 1 or x equals 8. But we do need to check these solutions. So it's possible that one doesn't work, or maybe they both don't work, or maybe they both do work. I don't know. We just got to see. So we're going to check back into the original equation. So I'm going to first check x equals 1. So let's see if x equals 1 is a good solution here. And I'll put a little question mark, not sure. All right, so it looks like we're getting square root 4 plus 3 equals 1. 2 plus 3 equals 1. Nope, 2 plus 3 does not equal 1. So it doesn't equal 1. That means that x equals 1 is not a solution to this equation. Okay, now let's check x equals 8. So I'm going to plug 8 in. All right, so I'm getting the square root of 25 plus 3 equals 8. 5 plus 3 equals 8. Yep. Okay, so 8 is a solution. So 1 was extraneous, but 8 is a solution. And so our solution to this radical equation is x equals 8. Hope you found this video helpful, and I hope you have a better understanding of radical equations. Thanks for watching.